students, I hope you all are doing well. In this section of our video, we'll be going through another important concept of chapter number 4, magnetic effects of current, that is an ammeter. What is an ammeter? Let us go through the circuit and observe the concept of ammeter, and let us observe how we can make an ammeter by self. So, as you can observe, you have a simple diagram of an ammeter. The basic working of an ammeter is that it is simply a low resistance galvanometer which is used for measuring current in the circuits. It basically measures current in amperes. Ammeter is normally connected in series. If you observe this diagram, you observe a galvanometer and a shunt. So in order to convert the given galvanometer into an ammeter, we are required to connect a low resistance shunt in parallel to the galvanometer. The combination of this galvanometer and a parallel connected shunt will create an ammeter. So in order to calculate the range of this ammeter, we need to calculate the magnitude of this shunt which is connected across it. So let us observe the few basic parameters. Here G represents the resistance of galvanometer, N represents the number of scale divisions of the galvanometer, K represents the figure of merit or current which gives a deflection of single scale, current for single scale deflection. Similar way, the full scale deflection current, that is Ig, can be calculated as N times of K, that is number of divisions times figure of merit. Now, going through the calculation of the value of shunt to be connected, as again both are connected in parallel. So by Ohm's law, again voltage across shunt is equals to the voltage across galvanometer. Potential difference across shunt, I minus Ig into S. Potential difference across galvanometer, Ig into G. Therefore, the value of shunt comes out to be Ig into G upon I minus Ig into S. Ig into G upon I minus Ig. In this way, we can calculate the magnitude of shunt to be connected. Now, on connecting the shunt of S ohm in parallel to this galvanometer, you can convert it into an ammeter of range 0 to I amperes. Remember, I is the total current which is entered into this ammeter. So on connecting a shunt of S ohms, you are simply converting it into a range of 0 to I amperes. In this way, you can calculate the magnitude of shunt to be connected. Talking about the effective resistance, as both are connected in parallel, 1 upon R equivalent equals to 1 by S plus 1 by G. On simplifying, we have equivalent resistance GS into G plus S. So in this way, equivalent resistance of an ammeter can be calculated by simply applying the relation of equivalent resistance. As we have already studied that when you are connecting two different resistances in parallel, their equivalent resistances are given by 1 upon R1 plus 1 upon R2. So this was the basic concept of shunt. I hope you have understood this logic well. Thank you.